Okay, so let's think back to yesterday. So we have a couple statements up here with some blanks. You guys can fill in the blanks as I read them out. Let's see who can do it. So experiments need to be, what's one of them? Go ahead, Brianna. Reliable. What else, Linnell? Verifiable. And John? Controlled. Awesome. And you must keep all variables the, say it if you know it. Same. Except one. To make a good, solid experiment. Awesome. All right, so this is what we talked about yesterday, because yesterday we really had a completely out of control, unreliable, not verifiable investigation going on, right? With our paper towels, all sorts of stuff was going on, right? We had made the list of way too many variables, different amounts of water, different pressure that was applied, the can sizes were different, so they were throwing rocks on there with different shapes, sizes, weights. None of it was really making sense. We really couldn't figure out what would be any good results coming from that. So we decided that, you know what, we really didn't have a great question to start with, because we had said, which paper towel is better? So we had changed that to, anyone remember what our question was? We had now changed it to Danielle. Remember, those words were tough to define, but we used a different word. Do you remember, Mike? Absorbent, right. So, and we were absorbing what? What did we say specifically? Zach?
Which paper towel brand can absorb more water?
Excellent, yes. So we're looking to see which paper towel brand can absorb more water. So we thought that that was a very specific, measurable question that we could get some actual results from if we did a much better design than what we had yesterday. So that's what we're working on today, is we are going to make improvements on the design from the investigation we started yesterday. So to get through that, let's remember, we just said our question again, do Brawny paper towels have the ability to absorb more water than economy paper towels? But yesterday we had developed a list of things that went wrong, and you started to, at the end of the period, come up with a list of improvements. So in those improvements, okay, what were some of the things that you had already come up with? How many were able to at least come up with 2 or 3 changes before the end of class? Okay, so you know what? I'm going to give you a couple more minutes to talk it over with your partner and see if we can either eliminate some things up here altogether. Think about some of the tools that we used over the last couple days in our measurement lab, right? So I've got the tools up here on the lab table for you to look at. Think about it with your partner. What could we do to improve this investigation? Okay, some things could be eliminated altogether. Other things we can change into an actual science tool that we're using. So go ahead, talk it over and see what you come up with. We'll go through it in a moment. All right, so let's hear some of your ideas. What are some improvements that we could do for this? So I'm going to start with the first part here where it says different amounts of water. Did anybody fix that part? Okay, so Johnny, what did you say? Okay, so we want to use the same amount of water. And do we really want to just say the same amount of water, or should we give a specific amount? What do you think when we're designing our investigation? So that's a really good start. We want to use the same amount of water. Should we give a specific yes or no? Yes. So when we make our design, we want to pick a very specific amount of water. Okay, great. All right, what else could we do? How about different pressure applied to each towel? Did anybody talk about that at all? James? Okay, so instead of rocks, using quarters. Now I've heard different ideas. Some of you were talking about marbles, quarters, things that are exactly the same weight, which is an excellent thought. But here's one question for you. I checked in with one of the other groups and had mentioned it. Think about our question. Our question is, which paper towel has the ability to absorb more water? Do we need to be concerned with placing weighted objects on top of the paper towels? No. It doesn't have to do with our question. So we want to stay focused on our question. So that piece we can actually eliminate altogether. So we don't need any rocks or any other weight kind of thing. If we were testing which paper towel could hold more weight, would that be a great idea for that? Yeah, because quarters are the exact same weight, shape, all of that, right? So that would be perfect. So we just need to remember, we want to stay focused on what our new question is, which is the ability to absorb water. So did anybody put anything else about the amount of water or a tool they use that we could maybe add something to that? I haven't heard from you. Go ahead, Anna. The pipette. Good memory. Okay, so a pipette might be a great choice because that is something that has measurements on it, right? It can administer small amounts of water at a time. That could be a really good choice. What are some other things we were thinking? Anything else for the water piece before we move past that?
You could possibly also use a graduated cylinder.
Ah, and what would you use the graduated cylinder for?
To pour the water in the exact amount.
Okay, awesome. So we learned in our tools lab that graduated cylinders are the much more accurate tool for measuring, right? Much more so than a beaker, much more so than a flask, because those are approximate measurements, right? So on that graduated cylinder, we really can get some accurate measurements. So it would be a good place to measure out the water we're going to use for the investigation. What else could it be used for? Besides measuring out what we're going to put into the paper towels, it would also be a really good tool to measure what? Zach? Think about our end result. What do we want to see at the end? Sure. Stevie, you want to help him out? What do we want to know at the end of this, guys? We want to know which paper towel does what. Steven? Can absorb more water. So what might a graduated cylinder also be great for? Steven?
Like seeing how much water the paper towel has.
Seeing how much water the paper towel has in it? Or would that be easy to do? What's an easier thing to do? Danielle? You could do that, but would it be really tough to get every last drop out of that paper towel to make sure we got every last one? It would be really tough. What could we do instead? It's really tough to really measure what's in the paper towel, but what's much easier is what? Sean?
Wait, like you could weigh the paper towel after it's been wet.
That's not a bad idea. We could do weight. The only problem with that, there might be some drippage leaving, as we're trying to get it to the scale, but that's not a bad idea, measuring how much weight is in there. That would give us some actual numbers, so that's a possibility. Any other possibilities? Zach?
You stick the paper towel to the graduated cylinder and pour it out and see how much the water took out from the previous water was in it.
Okay, so we're seeing how much is left over. But again, when we stick the paper towel all the way in, are we going to have some dripping and maybe not have it as accurate as we would like? It might be that as a possibility, but you're on the right track of measuring what's left over, right? What didn't get absorbed. So that's what's left over in the graduated cylinder. Linnell?
Maybe put the paper towel on top of the graduated cylinder to see what drips from it,
Okay, put the paper towel on top of the graduated cylinder and see what drips through and add that collection up. Okay. So these are all great ideas to really think about where are we going to get the most accurate readings. So these are all things to think about when we're designing it today. Okay, so anybody else want to add any improvements that they thought about that we could add to our list here before we get started? All right, so that's a good start just to get the conversation going. But before we do the actual design, I want some volunteer to show me how to sharpen this pencil. So you're going to give me instructions. So from your seat, you're not going to actually get up, but using your words, you're going to give me the instructions to sharpen that pencil. All right. This work? All right, go ahead, Dustin.
So you take the pencil and you sharpen it with your finger.
You gonna keep going or you want somebody else to? Go ahead, pick somebody.
Okay, so pick up the pencil with your hands, or take it out of your mouth, and then only hold Get the sharpener.
With your hand.
With your hand. Where is the sharpener?
You can use the electric one, that's okay. You don't have to use that one.
Okay, walk over to the sharpener. Straight.
Keep going.
Little right.
Right.
Right. You go on. To the left. To the left.
Left. Stop.
Go backwards. Stop.
Left.
Take. Reset. Reset to the left.
3 steps to help you set it up.
Straight.
Move forward.
Stop.
Put the pencil. Put the sharpener. Down there. Down on the table. No, put the pencil. Put the pencil with the sharpener on the table. One more way.
Keep going.
Pick up the oh.
Put the hole in the sharpener.
Put the wooden sharpener. Oh my god.
Put the pencil in the hole.
Straight.
And push.
Push.
Oh, my finger.
Alright, so poor Steven was like victim. Who can tell us why was I doing that just now? What was I trying to show you? Go ahead, Brianna. Oh, sorry, Serena.
Because the instructions for an experiment, you have to do like exact, and the instructions have to be exact.
Good job. Yes. So when you're creating your designs today, right? Poor Steven and Dustin were my victims here. But their instructions, were they very clear? Not exactly. Now, they assumed that I actually knew how to sharpen a pencil, right? Which I do, but I was acting as if I didn't. So when they were giving me my instructions, I didn't know what to do because they weren't exact and specific and clear. So when we're making our designs today, we need to make sure that we are very specific and that we are, no matter who's picking up our paper to do the lab, whether it's Zach or Brianna or Alex or Stefano, doesn't matter who picks it up, they all need to do it the same exact way. And it has to be in a written word, just word for word, what are we doing? What tools are we using? What type of tool? How are we putting it on? What height are we doing things from? What time are we doing it, right? So you want to think about all of those things. Because as we said in the beginning of class, all variables have to be the same except one, okay? So when you make your design, I want you to just look at this one example. Again, this doesn't necessarily mean that this is one that you should use, but this is a past student had started out with this. So you are going to be doing a step-by-step design. Step 1, place one brawny towel over a 500 milliliter beaker. You may not want to use a beaker, right? This is just an example. But notice how they gave very specific, what type of beaker we're using. Oh, a 500 milliliter one, okay? Step 2, place one economy towel over a 500 milliliter beaker. Step 3, secure paper towels with a rubber band. Step 4, etc. You should have at least 13 steps going, okay? So think about all the improvements that we talked about as a class. I'm going to leave all these tools from our lab the last couple days up here so you can come take a look at them if you'd like and decide what you want to do with your design. So you could be as creative as you want with these tools. Ask me for other tools if you think of something else and you want to create a design. You're going to hand this in either at the end of this period or you can work on it tonight for homework if you don't finish it in class. So it's going to be on a separate piece of paper in your science journal that you're going to be able to tear out to hand in. So just make sure it's not on the back of any of your entries. And you want to make sure you've got a good specific design. And don't forget about the question, right? The question is, going back to it, do brawny paper towels have the ability to absorb more water than economy paper towels? So keeping that in mind, let's come up with the best design yet.